Okay, so we're going to talk about another variant of our search stream gang program called the SearchWithParallelSpliterator example. And we're going to use this example to demonstrate how a parallel splitterator may or can improve the performance of parallel streams. And this particular solution will help to address a limitation with the previous approach that we did, where we were able to get even faster, more scalable performance using additional parallelism than we had been able to do with the more straightforward approach that just made all the streams parallel streams. So this is going to go kind of one step further. So this is yet another in a sort of large number of examples. It's about a dozen different examples of different ways of doing the search stream gang program, some using sequential streams, some using sequential loops, some using parallel streams, different variants of parallel streams, different variants of completable futures, different variants of RxJava. So if you want to see kind of the Rosetta Stone of concurrency mechanisms, take a look at this example. Right now we're looking at the parallel streams version with the splitterator. So this uses parallel streams in three ways. The previous approach, the SearchWithParallelStreams, used two parallel ways. This is going to use three, so it's one better. So obviously it's got to be better. The first thing we're going to do is we're going to search for chunks of input in parallel. So basically each work of Shakespeare, this is what we're searching for, is going to be run in parallel. So each of the works will be run in parallel. So that's one model. Second thing is we're going to search for chunks of phrases in parallel. So we're going to take the different phrases we're searching for in the works of Shakespeare, and those will also be run in parallel. And then the third thing, which is the new thing that we didn't have before, is we're going to search chunks of each input string in parallel. So we're going to go ahead and search things where the input string itself is going to be broken up into chunks, and we're going to search those chunks for the phrases in parallel. So it's three different ways of doing parallelism. So this approach, the SearchWithParallelSpliterator approach, is the most aggressive parallelism strategy. It's got the three heads of Cherubus or whatever, trying to get all the computations chewed up as quickly as possible. Here's a little illustration of the benefits of doing it this way. I wrote a little program called SearchWithParallelSpliterators, or I forget what it's called, but it's basically an approach that will run all these things with different phases done either sequentially or in parallel. So it does all the permutations of three different approaches where you can have either each approach parallel or not. So there's 8 total approaches here. So at the low end of the scale, in other words, the slowest, because it's completely sequential, we use sequential splitterators, we use sequential phrases, and we use sequential input. So everything's sequential. And you can see that that's the performance that we get. And then we go through and we systematically vary every one of those things. So you're either searching in parallel for splitterating, you're searching in parallel for phrases, you're searching in parallel for input or not. And as it turns out, if you crank everything up and run everything in parallel, that's the performance you get. And this is for each of the works of Shakespeare searched individually. So you can see that this approach gives us the biggest bang for the buck. Interestingly enough, I also had another variant where I took the works of Shakespeare and I split them up into 2 parts. And so there was like the first half of the works of Shakespeare and the second half of the works of Shakespeare. So this is just like much larger strings. And as you can see, if you look carefully, you get a little bit more of a speed up using longer strings to search than if you use shorter strings to search. And so the thing to come away with from this is if you have larger input, you may get a better opportunity to leverage parallelism because, of course, you're splitting that large input up into chunks, and we're searching those chunks in parallel. Now, it's not wildly better, but I've only got 6 cores on my laptop, so it's only going to go so much faster. If I had a 1,000-core processor, I might get even better speed up, especially if I had larger and larger input data sets to search. As with the parallel streams version, where there was just one little change from the sequential stream to the parallel streams version, we changed stream to parallel stream every place we had a factory method. This has one other minuscule change too. Whenever we call the search for phrase method, we pass in true. And that triggers the use of parallel searching for a phrase in an input string instead of sequential searching in an input string. In other words, the input string itself will be broken up into chunks and searched in parallel. And so what we're going to do in this lesson is look at how all that works. Here's what the search for phrase method looks like. It takes in the phrase that we're looking for, the input, which is a work of Shakespeare, the title of the input, the title of the work of Shakespeare, and whether we're running in parallel or not. And then it goes ahead and it uses the streamSupport.stream method to create a parallel stream that will search the input in parallel. So we're going to use this thing called the phrase match splitterator, and we're going to split the input string up into chunks and then search for this phrase in parallel in those chunks. And I'll walk through that. It's really, really cool. It's complicated, but it's cool. And what determines that is what the value of this parameter is, whether it's parallel or whether it's true or false. And as you can see over here, we set it to true for the SearchWithParallelSpliterator variant. For SearchWithParallelStreams, it was set to false. We weren't doing the splitterating in parallel. OK, so that's just a quick overview of the example. It looks very similar to the one we had before, but you'll see in a second that the behavior is different, and the most important thing that's going to be different is the way the splitterator is used will be very different.